All right. Hello, everyone. So we're starting with some background music, but I will get that out and share my screen. Let's see. All right. So I will just quickly resume from the previous presentation. I will just go through one slide so that we will then move into the code with a general understanding of what we're trying to achieve. So I will walk you through the code required for analyzing a list of long tail entities, long tail queries that I have created based on the analysis of the content that we have on the test website. The test website, it's running WordPress and WordLift, and has 70 articles taken from ZDNet that covers different topics around knowledge graph and data and artificial intelligence. So we will have a look at the way in which we are going to group these intents using entities from the knowledge graph that we have created with WordLift. And then we will also look at the way in which I analyze the results from Google, and because this is the way in which we then group the content from the website into the page that we end up building. So to give you a little bit of a context, that's a little bit of this is the structure of the page, where we have a long tail query that we have identified as valuable in our context. We have an introduction paragraph that introduces the topic that we generate using a summarization, an abstract summarization that uses Google T5 and the Transformer library. And then we have a list, not of products in this case, but of articles from the blog. And then we have another widget that allows the user to browse with, related content within, the scope of this query. And then here is not represented because it's right below. There is another block that contains FAQ. So we kind of start from the end with this session by kind of looking at the page. So that's the page that we have built using WordLift, that it goes after an intent, which in this case is artificial intelligence in healthcare, where we saw that there is a demand. So there are people that are making these searches, and we do have enough content. We do have enough content in our blog to group articles related to this topic. And then we have generated this first block here with the abstract summarization. We have placed this widget here, which is part of the widget that WordLift provides, where the user can, much similarly to what we see usually on Google, the user can filter the article using the entities that are related to this article. And then we have other related articles that are being added here, and the selection of this article, it's using an algorithm that uses the analysis of the entities that we detect from Google search results. So this is another collab that I share today with you that will allow you to dissect the results behind a query using the network of entities that you can extract from these results. And so if we kind of look at the way in which this content has been selected, then we know that WordLift is trying to match the content that it finds, the entities that it finds in the top results with, the similar entities that he has within the knowledge graph. And then last but not least, we have two questions here. So one question here and one question here. And then we have also WordLift has written the response to this question using the same technique that we used for generating the intro. So we have an intro, we have an interactive widgets that allows me to kind of choose topics and filter out content that can be related. We have a listicle of related articles that supposedly match what we have seen on the Google SERP. And then we have two questions and their respective answers. And these two questions have been extracted from the People Also Ask block for this query. So we will see how in the code to go and get these frequently asked questions and then create the text. And then, of course, the text it's added back into WordLift. But I mean, this is more kind of the mechanics of your CMS. Now, in this work that we're doing, we are also providing an endpoint inside the website for rendering the content in the form of a JSON file. And as you can see here, so that's the block that contains the introductory text. And then here you also see some of the results of the behind these JSON. So this is the JSON that sits behind this page that we have generated. Okay, and within this JSON we also provide the list of entities that we have detected from the top results. And here you can see that some entities are extracted from the rank groups number 1, and these are the entities that we will use to find the related articles inside our blog using the knowledge graph. And here you can see that this is the navigator, which is this element that recommends the related content to the user. So this stuff over here, it's basically presented over here, and then the faceted search widget is also kind of presented with this list of articles and related entities within the context of this JSON. Now, the reason we do this is that this mechanism doesn't work only on WordPress, and a lot of and there is a strong movement actually moving outside of WordPress and while keeping WordPress as a CMS. So the reason we have kind of developed this new long tail feature as a JSON endpoint is that you can consume this data and use it, with your own headless CMS or whatever you have. So, we are providing, the data and the structure of the page that then can be embedded in whatever front end. So, George, we can add it on ZDNet. We're ready. When you're ready. Okay, so now before we start with the call lab, if there are questions, thanks Ryan for approving the music choice. As you've seen in the previous session, Notorious B.A.G. has a purpose in this presentation. So are there any question that we should consider answer at this point? Is it everything clear to this point on the type of work that we're trying to do, and do we have questions of any sort? I can see that Sam is asking a question. Go ahead, Sam. All clear. Okay, no, Sam is it all clear? Okay, so okay, that's good. Good to hear. Okay, so so we are getting the intents. That's the first things that we do. And so now I have linked this presentation in the previous session. I'm gonna just share the link again with you because at the end of this presentation, you will get also the links that will allows you to test the code yourself, and hopefully it works. So we will start with the first collab that contains, that I call long tail, that contains the code that from a set of potential intents will help you use a word-lift knowledge graph or whatever knowledge graph you might have, and organize this intent into cluster, and then plugged in keyword data to these intents to filter out everything that doesn't have enough volume. And then once we have identified the intent, we will proceed in the course of the script with creation of the content that we have seen into the page already. Okay. So that's the version that you have, and if you are not familiar with Colab, Colab is a cloud environment for running a Juniper notebook that we can use for running a Python code, and that we use for prototyping our tools and upcoming services. So the only thing that you need to do is to have a Google account or create one Google account, and then from this link you can make your own copy, save a copy in your Google Drive, so that you can start running the code. And when you run the code, Google is reserving for you a virtual machine, and then you can start following with me the process that we're going to see. So I'll give you a minute to get the first link, which I'm going to share also in the chat, for these first collab that we're going to work on, and you're just gonna copy the collab within your drive, or whatever space you have on Google, and running it with me, and then you can interrupt me at any time for asking questions or why I did it in one way or another. I think out of these stuff, what is important is that as an SEO, you, or as a marketer, or as content editors or journalists, you understand the approach, because the approach will remain valid regardless of the fact that the technology will change. And as I said in the previous session, something that we are seeing today, it wasn't nearly possible 6 months ago, or even less. And even today, I had to rerun the code again, and there was yet an update of a library that kind of blocked some processes that I was using. So there is a continuous evolution going on. So what is important out of this stuff is that we get the approach. So we understand exactly what we're telling, what we're going through. All right. So do you see my screen? Can you see my screen? Yes, good. And did you create already your own copy of Collab? You don't need to be kind of a Python expert. I want you to grasp the process, and I want you to grasp the approach more than the code itself. Also, because I'm not probably the most, you know, I don't feel that my code is good enough. But I think the approach is good. The code probably before, I mean, usually what it happens is that I have an idea, I start writing code, I test it, I try to see if it works, I test it with my clients, I get the opportunity to see if it makes sense, and then if it does, then we kind of industrialize the, you know, the version of the code, and we make it a, you know, kind of robust enough to become part of the product. So here, you will find the key, a WordLift key. So this is the key that it's linked with the knowledge graph in this website that we have set up for the demo, which is called knowledgeconnection.wordlift.io. It is not accessible to the search engine, of course. Only used for the purpose of this workshop. And here you see the components that generates the long tails, and we're kind of now going through the behind the scene with the collab and try to see exactly, you know, what are the steps taken to compose the page that we see here. So WordLift has you know, creates a key. When you activate WordLift, you have a key. This key, it's bound to a knowledge graph, and we are going to use this key and the knowledge graph behind this website to run our experiment. The knowledge graph in its most simple form, it's made of the entities that, you know, that we have inside the vocabulary, so the terms, and then it's made of, you know, the articles that we have here represented as post. So we use a key, and basically as I scroll down, you're just gonna hit play and run the cells, and then we will you know, see what happens. So here we are downloading a list of intents. And this list of intents, I'm not going through the process of the way in which it is generated, but you've seen it before. I use the Google Auto-Suggest to create this list of intents. You might have, you know, your list of target keywords. You might have, you know, created this list in so many different ways. But here we're going to use this list. And so you can keep on playing here. So we are downloading a CSV file that I have published on Google Sheet, where I have my list of intents. Okay, so I have a list of queries that we have created using the autocomplete by providing machine learning, knowledge graph, and artificial intelligence as core ideas. And you can see that we have a few of these that have been generated by using the autocomplete API. So we have 1,147 intents. And I'm not going through the process of generating this list again because it takes some time. So here I just made the list available so you can download it. And then we create what is called a pandas data frame. So we create a data structure in the code, and then we get the intents, and then we add two columns, one column for the entities and one column for the types. And so in the beginning, we just have the list of intents and no entities, no types. Now here, you could use Spacey, that is a natural language processing library that does name entity recognition, and it supports different languages, and it's you know, I use it a lot for running experiments. It's very versatile. So I put you the code here that you can use for extracting entities out of these intents. The reason I'm extracting entities out of these intents is that I want to group them to see, you know, the ones that are more closely related to my site. So I want to use the knowledge graph as a base for organizing these, you know, thousands of intents that I have generated with Google Autosuggest. Now, in our case, we will use the key that we have, and we will use WordLift name entity recognition and the knowledge graph behind the website. And as you can see here, we're using the staging API endpoint so that we don't mess up with the production environment, and we can, you know, freely run these. I mean, I don't think we have too many people running, so it should be okay. But so here, all I'm doing is I'm creating a function that, given a text, given a language, which we have set over here to be English, and given a WordLift key that it's bound to this website here, it's going to analyze the intents that we have created. Okay, and so this function will give me the entity and then the entity type, or the main entity type. So we have these APIs in WordLift that, of course, you can use when you work outside of WordPress in order to use our name entity recognition. That is in a way more specific than Spacy, because it does name entity recognition, but it also does entity reconciliation, which means that it provides a lot of data from the connected data sets like DBpedia and Wikidata and whatever we configure as part of your content analysis API. In this case, we will only use the label and the main type for the entity. And then here, when you will hit run, we will start to iterate through the data frame that we have created with all the intents. And for each query, we will you know, call the WordLift API in order to extract the entities. And we do this by using the string to entities function that we have defined over here, that get the text, gets the language, gets the keys, and then calls the APIs for the content analysis of WordLift and extracts the entities and the types of entity. Okay, so for each query, we are going to get entities, a list of entities, and a list of types. Now, as this one runs, it might take a while because it's thousands of calls. Is everything clear and running so far for you? All right, cool, awesome. All right, so Ryan, you probably need to run the first cell where we create the data frame. So I can see extracting entities from queries, name errors, name DF is not defined. It means that you need to run Olesia. It's a pleasure having you here with us today. So Ryan, you need to run the first this first cell. So you have to run every cell that I run in order for the script to work. So you have to run the first one, and then here where we get the data from Google Sheets, and then specifically this one will create the data set from the CSV that we download. And then you should see this output when you play on this cell, okay? And if you do this, then you should be all set. Yeah, no worries, no worries. I mean, just follow me step by step, and then of course you can, as I progress, then of course you can make changes and play with the code, and you can do that anytime because you will, the code is yours. And I will keep the WordLive key running for some time so that you can, you can play with these anytime. And also, this is the reason I also provided you with the same functionality in Spacy, so that you're not bound to use these process with the WordLive key. Some of you, of course, are already using WordLive, so they can have fun and use their own key and try to see how this would work with them. So we have iterated through the queries, and then we can have a look at the list of intents. Okay, so we have now augmented the intents in order to have for each query the list of entities. As you can see here, we have an array of 2 entities: machine learning and data science. And here you have the list of types. Now, there is one interesting aspect about these call that we make to the content analysis API is that here we are using the scope. So these parameters here in the WordLive content analysis API will instruct the content analysis to only use entities within the local vocabulary. So this is interesting because it does what Spacy doesn't do for us. So rather than using the set of entities from our trained model, which is trained using Wikipedia, we restrict the results to only the entities that we have in our knowledge graph. And that's pretty powerful. But you can also change these to global and rerun the process again and see that you will get a more diversified set of entities. And the same will happen if you run the same process with Spacy. So these two are alternatives. If you run it with these, you just open these. You can run it, and then you will need to go through the iteration running this cell. Okay. So at the end, we have a table that contains for each query the entities behind the query, or the entities that have been extracted for the query. Of course, some queries, some intents might not have the. Let me see if we get a broader sample. Remember here we have 1,000s plus intents, but yeah, most of them have WordLive has detected entities from most of these, because of course we're kind of limiting the scope to specific ideas that we have seen before being well covered in the content that we have. So but yeah, remember that we are just saying kind of a subset of the intents, but in reality we have 1,000 over here. So now we're gonna kind of cut it short, and here you could do it in a much more sophisticated way. But in order for us to analyze it with the keyword data, so with the keyword data coming from the analysis of the volume of the search volume of Google, we limit these results to 700 queries. Here, of course, you might have already started to use the entities that you have grouped over here to say, hey, give me only the top 300 for, let's say, artificial intelligence or artificial intelligence and health. Okay, so here we're just kind of cutting and getting the first 700, because 700 it's already a lot for us to kind of analyze. So we have to analyze 700 intents in order to get to a subset of maybe 1, maybe 10, maybe 20. This is also an important consideration to make, that when you create these long tail pages, you probably don't want to create 1, you don't want to create 2, you need to create a consistent cluster of pages that then you can start linking one to another, because of course you want Google to index these pages, and so you want to create a consistent user experience. Here in this example, we have created simply 1, but in reality, you're going to create a lot more, but not too many. You want to link them together. You want, these pages to be well linked, because if they're not well linked, they will, suffer and not necessarily being indexed. And so these entire things will kind of get lost. So here we're going to get keyword data. Okay.
Excuse me, Andrea, quick interruption. Your screen sharing needs to be enabled again.
Okay, sure. Sorry. So stop sharing. I need to stop and yeah. So yes, so Ryan, you can use your own keys in order to kind of analyze these intents, and then you will get different results, which is totally, it's exactly the purpose of these processes that we see these. Okay, let me see. Larry also has a good question, perhaps beyond the scope of this class, but I'm wondering how you could apply these techniques to a new website or one with less content than in this example. So to be honest, it's hard to go after long tail traffic with a newly generated site, unless you have something very specific in your data that you can build pages on. And this specific approach relies on significant amount of content. Let's say that you probably need to have at least 30, 40 articles that can be used for because then you're going after a long tail intent, and WordLift is going to check the entities that it sees on the top results from Google, and then he has to find something on your site which is somehow closely related, because otherwise it's very limited the chance that it will rank. So for this specific approach, you will need to have, I would say at least 30 items. In your case, I mean, if you think about how many podcasts, Larry, you have on your site, I'm sure that there is a lot of long tail that can be covered with the terrific content that you have on your site. All right, so back to us. Here we're going to use an API that it's that WordLift uses, that we actually it's the data is coming from our partner WooRank, and this API, it's equivalent to the SEMrush or the mods or the Alexa APIs that simply get data from Google. Okay, so here we have a class which is a REST client that again goes to the endpoint of the API of WordLift, and it will get the key to be authorized. And then we will see how we will use this client in a couple of occasions. But just so you know, we get data from WooRank about Google search results, and we use this data to provide some of the unique features that we have. So here the process is that for each one of the 700 queries that now we have in our data sets, we are looking at the information about the SERP. So we are looking at the data from Google behind each one of these search intents. And the reason we do this is that we need to filter out the intents that do not have enough search volume, because a lot of these tools that you find around the web that generates ideas then provides you with things that maybe have been taken, like in this case from the Google autocomplete. But if a query is on Google autocomplete, it means that someone might have searched it, but it doesn't mean that there is enough volume. So here, of course, it's depending on the case. But so I'm running here this cell to get the data from Google keywords data. So this data is actually the Google AdWords data. So you could also kind of bypass the WordLift API or the SEMrush API. And for this specific data, it's available through the Google Ads APIs. But we have wrapped it up into our own stack because we use these. And then you can see that now for each one of the query, we have we have a new data set basically that it's a new data frame that we call keyword data frame that contains the location and the language and then the level of competition and then the CPC, so the money that you need to spend for advertising on this keyword, and then the monthly search volumes, and then here we also have the category. So these are information that basically Google provides, and then you also have the trend of monthly searches, so that you can kind of eventually filter out queries that have that don't have an uplifting trend. I don't do these. I just focus on the search volume and the competition. Now, when I say these things, is that you have to think as an SEO. You have to apply your own SEO strategy and thinking in a creative ways and act on the data based on whatever theory you have of the way things work, and that's super important. But I'm sharing with you openly the way in which I would process these list of intents. So now we are merging, the previous data set with the list of intents and the entities with these new data sets that has, the search volume and the competition. And now here we are kind of flattening this data because we want to start visualizing this data. So for each query, we are creating multiple rows based on the number of entities that we have. So you can see that the first query, it's split into 5 rows because for each row we have one single entity. Now this is just a data processing, and we do these using these series, which are part of the pandas, which is the libraries that we use for managing the tables, so that we can kind of flatten these. It's the equivalent of the transpose function in a Google Sheet or in Excel. Okay. So and then we start to install a library here that will help us visualize this data that we now have, that combines the intents, the entities, the types, and then the search volume and the level of competition. But before doing that, we can have a look at the top entities from these intents. So these are the top entities that we detected using our own knowledge graph from the 700 top intents that we are analyzing. Okay, and since we're using the knowledge graph from the site, we do have we can assert that these concepts are also mentioned within the content of our website, because these are entities that have been created by annotating the articles in the website. And so here we use these tree map visualization, whether here we are using an histogram chart. So these are different visualization that all use the Plotly Express object that we have initiated here, and that it's part of the Plotly library. So this is super versatile. And here I'm also adding NumPy that it allows us to make mathematical function on this data, and we use it for instance grouping stuff. As you can see, it's the commands are pretty simple. So the figure, it's the visualization, and then this is the histogram that takes this data frame that where we have flattened basically each query and each entity into one row, and then we are visualizing these and kind of grouping the top entity, and we're providing an order of the things. So if you run this is the first visualization that we create, and these it's quite meaningful because it's using the entities that we have in the knowledge graph to group stuff that we have within our intent. And as you can see here, we have a lot of different iteration of queries around, let's say, natural language processing. And as you can see here, it's interesting that, of course, WordLift is able to detect that NLP. It's a synonym. It's the acronym for natural language processing. So the quality of the data that we have inside the knowledge graph, it's actually providing, an extra edge when we analyze the intents to generate our new pages. So here on the top, we are using the labels. Now, this is less meaningful in our context because most of the concepts or all of the concepts are characterized as things, but imagine that in a more complex and evolved content model, we might have, for instance, a webinar, or in the case of Larry, the podcast. And so we might use entities that are of a certain type, and so here we can use the type to also filter the different type of entities, and then once we get into the type, then we can jump into it and explore this stuff, and then of course we can visualize it, and this is also good if you work as as Ryan doing SEO, then you can use these also for the clients, of course. So here we are plugged into the visualization a different path. So we do have the entities. So we're not using the types. Like here you see that in the path I'm using the types. So the object here is a tree map. The tree map gets the data sets and then a path. A path specifies the hierarchy that you want to use for structuring your tree map, and then inside these hierarchies, then you can say that you will use the color for grouping entities, and so in this case you can see that knowledge graph it's orange and artificial intelligence is red. Okay, but here we start to use the color for conveying an additional information, which is the search volume. And we remove the types because we've seen that in this specific case, the types are not kind of relevant. They don't help me filter the different content types because I only have things in my knowledge graph. But in case here I find different types, I might also keep the types within the path. But here I'm removing the types and I have just all, which is it allows me just to group the stuff at these levels, so I can always come back. When you work with this stream up, then you will find this. It's kind of a way of getting back to the original visualization. So you want to keep these all running, and then here I'm using as values. So the size of the box here are becoming more meaningful. Here there's no meaning in the size of the box, but here I'm adding the search volume as an element for the size of the rectangle, and I'm also using the same for the color. Okay, so quite obviously, artificial intelligence has more volume than machine learning versus artificial intelligence. And that's pretty much the way we want to use it. I mean, machine learning has more volume than healthcare, and of course has more volume than knowledge graph. Here again, it's the SEO in you. or the marketer in you that helps you kind of get these data to the point where you can act on it. So we just want to get enough data to the content editors, to the SEO. And here we're using another lens, and of course I could have combined these lenses into one single visualization, but for the purpose of explaining the way in which things works, I prefer to keep these two visualization separated. So this is intent by search volume, and this is intent by competition. And here also we want to think, that maybe we want to go to a super to the least competition. And that's what we've chosen in the end, because artificial intelligence health is the one that has a good degree of volume, and some degree of volume. It is within the context of health that we that we cover on the site, and as the least amount of competition that we can find. All right, so I will take a short break now, so for you to ask any question, and also we can take a very quick break. Just discover comment function. So yeah, you can comment there. It's like Google Drive basically for writing code, and it's very interesting for kind of sharing stuff. Yeah, just a 1 minute break, and we will be back. And based on the ideas, we will propose a list of potential intent, and then the editors will just pick one, and then we will build the page. So we will we will create the data, we will get the data that is required then for the CMS to render the page. So in workflow terms, then the editors just will run these by starting from the first ideas, and then it will choose a subset of these that we think relevant, and then based on these we will create the page that we can start building on. And so in order to build this page, as we've seen, the APIs that then we have already creates the intro text. So it already gets the data from Google for that specific query and all the entities behind this specific query that then are used for finding the good match with the entities inside your website. But then we automatically summarize the content out of this SERP, and we generate this text that then is annotated by WordLive, so that it also contains links. Now, the next step of the process is to, since we now have the entities behind the queries, and then we can, kind of automatically create the list of related articles. So this is, a result of the analysis that we do of the entities behind these results. And this analysis, it runs, it is explained within these other collab that I share with you in the presentation. So I'm just going to add the link for this other collab, which we will probably not go through today, but you can use, and then you can write me. So this one is where I analyze. Oh, no audio. Are you guys listening to the? Can you hear me?
Yes, that was a few minutes back.
Okay, good. Okay, it's also check to see that you're still awakened. Okay, so this other collab that I just shared is the one that basically runs the SERP analysis. So the mechanism, the procedure that we use for understanding the entities behind the SERP. Okay, so here it's an explanation and a good visualization of how we get to this list of entities that you see here. Okay, so here we have the JSON that WordLive creates when the editor chooses a query like artificial intelligence in healthcare, and then this JSON contains the entity that then WordLive uses for selecting the related content. Okay, so since this is pretty much covered, then we start looking at the way in which the questions can be seeded for this query. Okay, so we continue here, and here of course you can play, and you can say artificial intelligence in I don't know what sectors we can try artificial intelligence in SEO. So that's a query that you can try, and of course this is your target long tail query. And here once again we are using the WordLive API that rely on the Google SERP data. So here the important parameters are the language of the SERP, and then from where you're making this query, and these are the location code that Google uses in Google Ads. So here we are running this query, and let's see if it works. It should give us the list of queries that so these APIs analyze the Google results and can provide us with the list of queries. Okay, and here you see that what is artificial intelligence in SEO, what is artificial intelligence in digital marketing, what are some examples of AIs, does SEO have a future? That's an interesting one, so I'm going to use these. So this is a plain simple. People also ask data that we can get from the WordLive API that allow us to do analysis of the SERP. This is data that we currently use in the product, and it's accessible to some of our clients through the APIs. So what do we do now that we have a question like, does SEO have a future? We want to get the results, and we want to, prepare for, generating a text that we can at least suggest to the editor as a first draft. So we don't have, we don't pretend to write something meaningful in the first place, but we pretend to suggest the first draft to the editor. And so here, I am using a library which is called actually Google. That all it does, it basically, it's kind of something similar to what this one does. It goes to Google SERP, and then I'm using a library that is called Trafilatura that will remove from a web page any element that is not textual. So this is a way of like kind of cleaning up the HTML code of a web page to get the text out of it. And here I'm using the transformer by Hugging Face, which is kind of the AI part that will allow me to generate the summary from the content that I scrape from the Google results for the provided query. Okay, so here I am setting the version. Yesterday, Hugging Face announced that the Transformer version 4 is available. So I had to block it to the previous version, which is 3.5.0, because version 4 doesn't currently work with this code. I still have to understand it. As I said, it was out yesterday, so I usually spend some time to understand what's new. But by doing this, we can just load the previous version of the transformer. And now we run the query on Google so that without using our key or without using third parties APIs, you're able to quickly get to Google and get the results from Google. And here we have this function which is called get results that will get a query as input. We'll get a top-level domain for Google. This means running the query on Google IT or Google Com or Google D, so whatever geographical areas you want to explore, and then it would get the numbers of results that you want to process, and then the beginning and the end of these results, so that you can kind of look at, for instance, results from 3 to 7, or from 0 to 1, and so on and so forth. So this is a function that will get the list of results. Okay, simple as that. So the list of 10 blue links, URLs that rank for that query. Now, this is a function that uses Trafilatura, which is this library that removes everything that is not the text, that will get the URLs and the query, and will output a list of URLs and the text that has been extracted from these URLs. Okay, so this is where really the magic happens, and we get the text behind the web page. So this is a basic data cleaning processing function. It gets the text and then removes any special characters from the text. And yes, data cleaning, it's of course of extreme importance if you then want to generate new content. Here I'm using T5 and a specific version of T5 that has been fine-tuned for news content in English. And this has been done by Manuel Romero, but then the original code for fine-tuning T5, it's by Abhishek, and here I'm using the transformer in order to import the tokenizer and the model that has been fine-tuned and made available by Manuel Romero as part of the transformer libraries. So here, what is happening is that we are actually loading so we have loaded the library, and now we're loading the language model, and we're not loading kind of the vanilla language models, but we are loading, the version that we need running the specific summarization. And here is where, the magic happens. And also here it's where, you kind of start to realize that what we discuss here about the limits of these language models, that, they do have, they don't generalize well. So I'm using a model that has been trained for news. It's good for news content. It might not work well for your e-commerce website. And so you might need to fine tune your models for working on, generating, for instance, the meta description for your retail shop, or, so I'm using a specific, fine-tuning that has been done on news content. And here, so we are loading the model. We are getting the text that we have scraped, and then we are providing the models with a text that gets encoded with the tokenizer. So the tokenizer will transform basically whatever text into numbers. And then you will truncate the text after a specific number of tokens, and then you will decide in this case to use PyTorch as an infrastructure to run the tokenizer, and then you will call up the model and generate the summary by getting as input, of course, the tokens that you have obtained from the tokenizer, and then here these are kind of the parameters that you can use for playing with the function of summarization, where you can provide, for instance, a penalty that can be higher or lower when the models repeats content, which is something that might happen, and then you can apply a higher penalty if you for instance want to control the length of the produced content. In this case, we're not too strict on how long the content should be. So these are the parameters, but feel free to play with these parameters in your notebook, and let's see what we get. So we got a question here that was, does SEO have a future? So I'm going to use these as a kind of a starting point for the query, because I have obtained this question from the query about artificial intelligence in SEO, and then I'm just going to run this process through, so that we can provide and generate a text for this specific question. And as you can see here, we are kind of visualizing the results that we are analyzing, and we have we're looking at the top 3 results we're looking at the top 5 results for this query. So we are using the get results function that we saw above, and then for each one of the results, for each one of these URL, we are extracting the text behind, and then here I am filtering everything that is at least 200 characters long. This is because you might get into, let's say, a tweet as a result in Google, and so a tweet, if you add it to the block of content that you want to summarize, might not be meaningful, or maybe it's even too meaningful. So I tend to remove everything that is not at least 200 characters long, and then I create a body of text. And then this body of text, which is called full body, it's what we're going to summarize with the models that has been trained on news using this function here, and then we should get the results. And here you can see that, of course, there is a lot of process running behind, because it is intense. And now let's see what we get. SEO professionals are now required to become storytellers and professional marketers that not only can develop a search strategy, but can also communicate and sell a brand online. The digital message must meet the user mindset and intents and deliver what search is seeking, while building brand awareness in the long terms. SEO professional must be intuitive and getting the right content. So I would say that this doesn't, really, I mean, it provides some insight, but it's not really the answer that, we were looking for. So some of the results that we get are super good and only require the editors maybe, a few touches. Some results can be, completely off. Like in this case, I mean, there are some, probably there are some good ideas out of these stacks that we could use, but definitely something that we will need to work on in order to go live. Or I mean, content is very subjective, but I wouldn't publish these as an answer to this question personally. So is everything clear so far? Yes, Ryan, that's the good blog post. I haven't personally tried GPT-3. I mean, I read a lot about it. I know that it's going to be part of the Azure stack, and WordLift runs on Azure. So I know that at some point we will have it available as part of the Azure offering, but I haven't tried it. What I've seen is that I don't expect that this problem to be completely solved. Of course, some of these problems might be solved. Probably a question like this will get with GPT-3 a decent answer. But again, here I'm doing a slightly different process. I'm crawling Google results in order to provide the answer. In other cases, I can train the model to give me answer if I have enough data. Yeah, the problem remains unsolved also with GPT-3. I mean, and using it right or wrong, it's not so trivial to use this stuff in the right way. I found that this approach that you're seeing here, where I go and get the results and then I summarize it with a language model that can be T5, it can be something else within the context of the transformer language model, do create some value for the editors, especially because, of course, I'm capable of, at the very least, of creating a synthesis of what is ranking, which is in any case informative for the editor. So my goal is not to replace the editor, but to sustain his work and make it simpler so that he can maybe focus on interviewing people rather than kind of expanding the article with question and answers that are super relevant for making his content accessible, but might not be the core of the content. So I found that this workflow of going through Google and synthesizing the SERP, it's effective because at least I can provide something meaningful to what Google sees within these results. And as we see here in this example, I mean, it's not that the answer is completely off. I mean, there is something valuable about it, and it's also well written. Might not be probably totally original, I would assume, but it's still a good starting point. And I mean, this is not the best example for showing this. Now let's see how we can generate questions from text. Let's see what can be done. So here again, I'm using the transformer, but I'm using an amazing pipeline. So a pipeline is a simplified procedure built into the Hugging Face transformers that allow us to do very specific task, NLP task, in a super simple way. So it's the simplest and most effective way to use the transformers without diving into the parameters. You will then find yourself building your own functions like I did in this case, because then based on the use case and the type of content that you're working on, then you want to kind of fine-tune the parameters, which is not always possible with the pipelines. But the pipeline is the simplest way, and it's a good example when we have text. So let's get these text. I don't know. I mean, I haven't tried this before, but let's get this sentence here into these cells, and and remove what we add, or get whatever text you want. And let's have a look at the different ways in which we can generate text. So here I'm just importing the pipeline, and I'm downloading the model train for the specific question generation. So here the important part is that there are different pipelines that I can use for generating the question and the answer, or just the question. Okay, so here it's the first result, which, as you can see, is super simple in terms of code, because once the pipeline has been imported and I specify that NLP is the question generation pipeline, I can just call NLP and then send, whatever text I have. And then you see that the question is, who is required to become storytellers and professional marketers? SEO professionals is the answer. Not so bad. Again, not sure if I will use these on a web page, but it's not totally wrong. There's nothing wrong in using something like this. Here we are using another model, and so here you see that you can use the pipeline with your own model or someone else openly available model. Like in this case, that gives you the benefit of again, getting something more specific for your knowledge domain. So here the model has been trained with T5, which is super easy to train, because you have to give, in this case, a text and all the generated questions as input, and then you will train the models, and then you can use this model for doing what we're doing here. So we give it a text, and then we expect the model to generate. So I added this example because this model is quite interesting in terms of results. Not sure about this case. It is important to know that Bing and Google are also using these for choosing, so this approach of question generation for choosing the people also ask set of questions. So, so you can see here that, I'm getting more questions out of the text that I've provided. So I got one with the vanilla pipeline. Then as I plugged in these new model, I'm getting two. As I said, in some cases you might only want to get the questions, because then maybe the editors will write the answers. In this case, I want to do both, and so I'm using this specific pipeline for generating both the question and the answer. And so that's pretty much all I wanted to share for the natural language generation part. And we will then quickly review the audit of the website. Do we have any question? Do you find this approach valid based on your experience? I mean, a lot of you have tremendous experience with content strategies and writings and SEO. Is this approach valuable for you? What? Alessia's writing, good. George, what do you think? Are you still following? Okay, Ryan likes it. So Alessia likes it. Yeah, you see value. George, what do you think? As a writer, don't put your head of a developer, because then the developer will say it's good.
Actually, my developer part was not following, to be honest with you.
Good.
So Python is not my my strong point.
Okay. Yeah. I mean, but it's not a developer thing. I mean, it's more like does it make sense? Because that's what I'm focusing the most is, are these work workflow effective? Can we scale? Should we bring all of these into the product? Should we just bring some of these? I mean, I'm experimenting with these on different use cases, but I still have to question myself and try to get feedback. So what's your feedback?
I think it's more or less the way you describe it. Like this approach is a useful baseline that you can build on if you are, if you're aiming for the long take, basically. So for this specific use case, I think it makes lots of sense. But again, my question, and this is not specific to you, this is always, for any type of, suggested automation, like, okay, does the time that I have to invest to do that right outweigh the time that I will gain by applying that? If yes, then I will go for it.
Yeah. This is why we talk about long tail first, right? Because the reason is that with a long tail, then I can create a scale. So out of the articles that you published on ZDNet, I can create probably 30, 40 good long tail that will get traffic that you otherwise don't see, that I can generate with a little help from your side, not too much.
Mm-hmm. Yeah, I think it makes sense in that, in that context.
Yeah. So Larry, yes, I do work with content team, and what I got from the content team is that as George said, this is a baseline, and so far so good, meaning that I can save up to 60% of their time. Okay. Which means on average, probably we're talking about 40% of their time. So as George said, this is applicable on scale if I have, kind of maybe 10 pages up. If I have to work on one single article, then I have to kind of bring it into the product, which is what we do with some of the functionality that you're seeing here. These are, already available to our user. For instance, with the new summarization that is used for creating, for instance, the story highlights. So if we go on like this website here, and here let's see if this is a good example. But in these articles, we used, no, this is not a good example because it's a Black Friday thing. But let me try to see a news content. Probably it's more applicable. So here we are using our own, the summarizer that you see inside WhereLift to create these, bullet points that kind of make a short introduction to the story. We are reusing, whatever content the editor is written. The editor only, push the buttons and then reviews it. And then we also creates links to existing categories. And so they like these because it can, quickly provide a way for refreshing the content with minimum effort from their side. So in some cases, some of these kind of tweaks and specific algorithm can help the editor so that the content team is happy and we can build it successfully inside the pipeline. But yeah, I mean, for more type of premium content, then generating related question is a good support, because we can provide the editors with some more ideas about what to write. And then in that case, getting the content is, getting the question is already a good advantage, because otherwise they have to go to Google themselves. And again, it's also a workflow issue. We want to do things within the context of the, of the CMS. We don't want the user to move too much from it, because it will, will spend, lose a lot of time in moving back and forth. So. All right. So just to conclude here, I will quickly make the site accessible in reading, because I will need to generate a sitemap, and then I will block it. So here, as we move forward, there is a part of the code that I share with you that allows you to run the audit on the site, which is also an interesting exercise for understanding what content you have. This is less interesting for a site that is using WordLift, because of course WordLift content is already organized inside the knowledge graph, so I can more simply access to the knowledge graph. But I use these a lot for analyzing competing websites. And so here I'm using a library that some of you from the SEO world might know, which is called Advert Tools. And Advert Tools is a terrific library for analyzing sitemaps and doing a lot of things. We will use this just to get the sitemap into a data frame. So here I am accessing the sitemap, and now I will make sure that we block the search engine. You can put whatever sitemap you want here, of course. And then here I'm specifically looking at the blog post. And as you can see here, with a simple instruction, I can quickly create a data frame, a pandas data frame that contains the URL of the blog post inside the post sitemap of the site. And here again, I'm kind of expanding this data frame that contains all the URLs, and I'm using the function that we saw before that will extract the content from the site. And here I will let me run it for a limited amount of rows, so I can. 10. So here I'm going to analyze each URL in the sitemap in order to extract the entities. And here you can see the top entities for each one of these articles over here. Now, this is interesting also because you can use these for analyzing, for instance, with your own knowledge graph, the content of the competitors. And so if we go here, then we can kind of look at the entities behind these, and then here we can save it to a CSV file, which is also helpful. And then here we can count the entities. Now, of course, we have a very limited number of pages that we have analyzed, and then we can quickly use again an histogram to visualize the top entities out of the 5 page that we have analyzed. And this quickly provides an overview of the content that you have on the site in the form of entities. And this is, again, it's one way that you can use for analyzing a competitor, or analyzing, again, the results that Google is providing behind a specific query, using the entities in your knowledge graph. Yeah, that's pretty much all we have for today. If there are questions, we can go through them. If there is some step that wasn't clear, or George, you're muted.
Yeah, I didn't say anything. You didn't miss much. I just said, let's see if people have any questions.
Yes, entities are those that, so Alessia has a question, and she's asking, entities are those that happen the most often in the analysis, or which algo are you using? So here I'm simply looking at the top 5 entities by number of occurrences in each text. So there are, of course, different ways in which we can find the most relevant entities in the text, but I tend to keep things simple. So I look at the top number of entities by number of occurrences. This is also because WordLift already has its own way in which kind of prioritize entities from the analysis. So I don't want to add extra steps. So I get the top 5 or top 10 most recurring entities out of each post, and then I combine them across the entire sitemap to see, you know, what are the topics that the site is talking about the most.
So we have another question coming in.
Yeah. I hope that, you know, with this exercise, we have a lot of, you know, kind of, would be interesting to use BERT framework if possible. You mean for analyzing the content, or what type of use do you envision? For content analysis, yeah, I mean, we are using our own NLP with our own custom vocabulary, but of course, as we've seen, we can use you know, any transformer in order to extract the entities. The main problem that well, specifically for name entity extraction, the transformer are limited still in the interlinking with Wikipedia. So we do have in WordLift a new version of the name entity recognition that uses not BERT but Roberta, which is also kind of an evolution of BERT-like model. But we still struggle to obtain the same results that we obtain with our existing APIs for getting data from Wikipedia, which for us it's important because then it's what we use for creating the knowledge graph. So, but yes, I mean, definitely you can run the same process and use you know, BERT for extracting entities if that if you like that most. Let's see what Ryan is thinking now. Hey, are these sessions recorded? Yes, they are, I believe.
Yes, they are indeed. And yeah, you can catch the replay at any time you wish. Well, that is after we edit them and upload them, at least, which should take a few days.
Good. And then, of course, I mean, for Ryan and the other WordLift client, we can definitely arrange something specific for their use cases. And yeah, getting back to the content, it always helps get new ideas. Yeah. I know that you're working on content modeling, which of course it makes you know, kind of a richer knowledge graph, and then with a richer knowledge graph, a lot of the stuff that we've seen can be done in a more precise way, of course, because as you've seen here, we basically have you know, entities and articles, and all entities are typed as thing. So of course, yeah, there is a lot of, I think there is a lot of opportunity for, you know, people doing SEO in a different way, and content strategies in a different way to use these approaches. And I think there is a continuous evolution, and I learn a lot from all of our clients in the way in which this stuff can be used, and not every website is the same. And as we said, I mean, there's no universal law in SEO, so it's we have to be critical and look at the use case, and then be very honest in also analyzing the data. I think I spend a lot of time with with the team to make sure that that we analyze the data in the most detailed form, so that we see if things are working or not. Because I mean, a lot of the stuff might work, but it only works if it creates at least a 5% lift in the number of clicks, if that is what you're measuring, or if it's impacting on the number of sales for an e-commerce. So I mean, we have to be very honest with the data and the way in which we analyze it, because then we learn. Because a lot of the stuff that we do work, but a lot of that, not everything works. And the more we find out things that don't work, like for instance, we see here a process for generating question and answer. Usually, I mean, we can see a 30% lift in 3 months. This is what we usually say, and this is what we can prove with many use cases. But for instance, we've seen during this course that we can quickly add question and answers to articles. This is super valid for a lot of articles, but not for all articles. And it also depends on the type of publishing frequency that you have. Because if you are publishing news and you are adding, for instance, let's look at the content that George writes for ZDNet. If George will overstuff the new article with a lot of Q&A, while on one side it will probably make the content be more visible and will increase the number of impressions, then it will also, in the first 2 weeks, it will lose the advantage of being perceived as a fresh news. And it would immediately be seen by Google as a kind of an evergreen type of content, which doesn't have the same impact that a news has. Because a news in 48 hours reaches its peak. And so if you're building something as a news, unless the content specifically it's built with Q&A, you don't want to use the Q&A for that content, which you might do maybe a month after the article has been published. So all of this workflow then has to be kind of tested with kind of analytic background and an honest mindset to see it is working and to what extent is working, what type of content are benefit the most. We know that structured link data, it creates an impact in the impression and therefore an impact in the clicks. But every site is different, and there are things that might work on site A that don't work on site B, and that's why we have to, of course. I mean, it is true that conversion rate usually tends to improve. So Ryan is saying that he connects the middle part of the funnel with the bottom part of the funnel, instead of just going through the broad reach of the top of the funnel. This is also very true when we start to apply semantic annotation to a piece of content. We are providing additional insight to the search engine of what we are willing to target in terms of concepts, and therefore we capture more specific searcher. Okay, we get more specific search. So this is tremendously true in the context of e-commerce, because there you see that the more data you provide on a product or on a category, and the better you qualify the audience that reaches that page. And of course, now there are a lot of changes also due to the fact that Google is shaping this data in the form of product knowledge panels. So there is, also the user experience point of view that has to be taken into account. And this is why, you have to study schema, but then you also have to study the interpretation that the search engine has of that specific class at that specific point in time. So yes, but it's true that semantic annotation and structured data markup helps a lot with So there is another question from Biolesia. Website knowledge graph. What is better, place in root domain or move to subdomain? So we usually publish the knowledge graph in two ways. So either as a data set under data.wordlift.io, like in this case. So the triples that we have created from the articles and the entities are under data.wordlift.io, and then there is a specific data set. So basically within a folder structure, there is a data set. Or for instance, we use a custom domain like the Next Web. They attended, I believe, the previous session. They use data.thenextweb.com or graph.thenextweb.com. Medical Records also, I believe that they were, I think ACE is still on. We have their own custom domain. So having a custom domain does have its own, hi ACE, it's great to have you here. So a custom domain does have its own advantage because, of course, it strengthens the domain authority and it kind of helps you be seen as a data provider, not only as a publisher. So my suggestion would be to get a custom domain. But in some cases, if the site is too small, then publish it under our own kind of data repository. It also has its own impact because we've seen that Google does crawl the triple store. It does crawl the linked data platform that we expose. What it does with this data, we don't know. But we can see that the crawler comes, and we can see that the crawlers that comes are not the crawler that comes to your website. So they have different IPs. But we know that these can impact or might impact on the way in which the site is indexed. But we don't know if it's better to usually in the beginning we saw that in the Google Search Console you can see the linked data resources as links pointing back to the page. And that also explains why linked data publishing can be effective in SEO because maybe the search engine is also kind of seeing them as href links. Though we publish data as data, not as web page, and so the web page is only visible when you get there with the browser. But so my suggestion would be to have a root domain or a subdomain, but to kind of keep it within your own DNS, unless the site is small. If the site is small, it's better to leverage on data.wordlift.io.
If there are no more questions, we're kind of out of time here.
Yep.
And well, maybe one, but just to speak over the time that it may take anyone to type something in. If you, in case people want to continue the conversation, I've pasted in the chat box a couple of ways. So we have a hashtag on Twitter, which is SnowCon2020. And we also have a dedicated channel on Slack that you can use if you're, the Slack type.
Awesome. Well, thanks, George, for setting this up, for inviting me again. I hope you...
It was a pleasure having you, as always, I'm entitled to say, since this is now two years in a row.
Yeah. That's good. And thanks everyone for participating and kind of making the event unique, asking questions and kind of keep me thinking. And I know that a lot of you will come back and ask a lot of other questions and how we can apply these to your own site. Ciao, Sante. Happy to see you here also. Yeah, cool. All right, guys. Thank you very much for participating. Bye-bye.
Ciao, everyone. Thank you.
Ciao.